everyone, welcome to Recitation 6, where we'll be going over Module 7, which covers writing classes for our programs. So to give an overview of what this recitation will be going over, we'll talk about why we want to use object-oriented programming. We'll go over some object-oriented programming vocab. We'll go over creating an object and the syntax for that, dot notation, what it means for something to be static, the this keyword, and then why we want to use encapsulation and what a reference is. So some things that commonly come up when we get to Module 7 are kind of, why do we even have to learn this? How does this improve our code if we could write our code perfectly fine without object-oriented programming? And then, is this something that we've already been using, maybe without realizing it? So to kind of get into the motivation behind this module and just object-oriented programming in general, having these classes are a great way to organize data and methods. And this allows you to make multiple objects with similar data and behaviors without having to go through the work of rewriting large chunks of code to have that data and behavior. And then also, object-oriented programming allows you to keep data and implementation details secret. So this makes it so that we can call a method on an object or retrieve data from an object, but also keep some of it hidden if we don't want to expose all of that to the user or to someone using our code that we're writing. So what is object-oriented programming? Object-oriented programming is grouping related data attributes and behaviors into objects. Writing a class creates a new abstract data type. Within each class, we define the behaviors and attributes for objects of that class. So writing a class is much like writing a blueprint, and then the object is, I guess, the object created from that blueprint. So let me give you a situation to help illustrate the idea of object-oriented programming better. Let's say you're making holiday cookies. You have a cookie cutter and you use the cookie cutter to generate cookies. Each cookie is different, but has the same attributes as defined by the cookie cutter. So these attributes would be like the length, width, shape, and the occasion that this cookie kind of fits into. So the vocab that we would use to describe like object-oriented programming, classes, and objects. An object is an instance of a class. An instance is one specific occurrence of that class. The class is the blueprint, like I mentioned, of what an object is and how it behaves. The constructor is a special method that each class has to create an object from that class. And then static, something being static means that it belongs to the class. And then instance variable is an attribute that belongs to an object. And then access is who is allowed to view or call a certain variable or method. So going back to our cookie cutter example, we can think about the cookie cutter, the action of generating cookies or making cookies, and then those same shared attributes that each cookie has. The cookie cutter would correspond to the class, or the blueprint as we've referred to it before. So this tells us what a cookie will look like, but the cookie cutter itself does not provide any cookies. The action of generating cookies or making cookies and like pressing the cookie cutter into the dough is corresponds to the idea of a constructor method. So this is how you construct new cookies. And then the attributes that all of those cookies share would be the instance variables. So here's what our class of cookie might look like. So we have the attributes mentioned, so the private string shape. We have private int height and width. And then we have the constructor method, public cookie, and then we have our parameters that create this new instance of the cookie class and sets those initial variables within the cookie. So like I mentioned, here are the different aspects of the class, this time with highlighted, so you can see each of the different parts. So kind of to expand upon what we mean by like instance variables or variables that belong to an instance of a class. So let's say Dorian is a person. Well, he is a person. But Dorian has these objects or these attributes, and these attributes all belong to Dorian. So first name is Dorian, wears hats is true, and email is dorian@email.com. I don't think that's his real email, but yeah. These variables won't belong to all person objects. Obviously, there are other people that exist that aren't named Dorian, don't wear hats, and or don't have the email dorian@email.com. So on the side, you can see that there's me, and I belong to the person class, but I don't have those attributes. So um, similarly, the method introduce belongs to a person. Only Dorian can introduce himself, and that's something we can ask him to do, like kind of like calling that method. Um, and it doesn't really make as much sense to ask all person objects or all people to introduce themselves at once and kind of do a general call of the introduce method. Um, so here's another example of what the beginning of a class would look like, this time for this person example. So we have this public class person, and some of the attributes that we have, or the instance variables, are the private string first name, private boolean wears hats, and then private string email. And then next we have our constructor, which creates a new person given those parameters, first name, wears hats, and email. So then when we want to create an object called Dorian, we write the line of code person Dorian equals new person, and then with the parameters Dorian as the first name, true for wears hats, and dorian@email.com for the string email. So this is calling that constructor method to create a new object. So just to kind of further break that down into the components of creating an object. So person is the type or the name of the class. Dorian is a person. So that's why we have person coming first. And then Dorian is the name of the object. So that's going to be how we'll refer to that object going forward in our code. New is a keyword, and that indicates that we want to allocate new memory. And then person, again, is the type or name of the class. And then in parentheses, we have the constructor parameters. And so here's kind of that note on the new keyword. It just is telling us that we're setting aside memory. So this follows the pattern that we've seen of creating variables or initializing variables for a bunch of different things, right? So when we create a new string, we might say string Dorian equals hello. And so we're similarly indicating first the type or name of the class with string, and then we're giving the object a name, Dorian, and that's how we'll refer to it later on. And then we're assigning it a value. In the case of a string, here we would have hello. And then once we've created a new object, there is what we call dot notation. So if we have this object Dorian and we want Dorian to introduce himself, we say that we want to call the introduce method on Dorian. So the way that we do this in our code is using dot notation. And for this introduce method, what it would look like is Dorian.introduce. And that is essentially us asking Dorian or telling Dorian to introduce himself and use the introduce method. So that method is applying specifically to the object that is before the doc. We might have a bunch of other methods that we can similarly call using dot notation. So um, for the person class, we might want to have like a get first name method. So Dorian dot get first name would be calling the get first name specifically on the Dorian object.
All right. So you also might have noticed that in our methods previously, we didn't write static earlier, which means that all the methods, like let's say introduce in the person class, they're non-static and associated with a particular object, not the overall class. So the object Dorian has like these attributes such as name that belong to him, and like his slash my ability to introduce myself. Um but so yeah, like those methods related to those instance variables are all called on the specific object that those things belong to. And so belonging means that it's not static. Belonging to a particular object means it's not static. Static means the variable or method or whatever you're talking about belongs to the class, while non-static, it's only the object. Cool. So, continuing with this explanation. So, let's say what would happen if we make first name static? Well, that would mean all person objects share the same first name. So Abby, I, any other person that we made, they would all have the same first name, which doesn't really make sense. Everyone has a different first name. I mean, some people might share the same happen to have the same first name, but like not everyone has the same first name. So we don't want to make it static because then all people would have the same first name. Whereas if it's non-static, this first name property belongs just to the specific object. Like all people in the person class, um, or objects of the person class, do have a first name, but that first name can be different. So Abby and I can both have different first names. Awesome. But there's some things that should be static because they're the same for everyone or every object in that class. So all objects in the person class have the same species, Homo sapiens, and that makes sense. So that's something that should be static for sure. Um, or like, yeah, there's some like any other things like property that would apply to all people, like all objects in that class, that should be static. And so sometimes we do want to keep track of like data outside of one particular instance. And so we would want to associate it with the entire class. So let's say we were making like a video game or a simulation. Then we'd want to keep like track of the starting size for all like of a certain type of character. Like let's say all the enemies I wanted to have the same starting size. Then I'd want to make starting size a static variable since they all have the same starting size. Same with you'll notice in the zombie assignment if you do that one, module 8, starting size will be static. Additionally, colors to draw the characters with. Like say all the enemies I draw with a certain color or like a set of colors, then that would be static because they're common to all the enemies. Additionally, math.py. That's just associated with the overall math class, and so anytime you're writing like math.py or even any of the math methods, those are all static methods. Because it's like associated with the entire math class. Like you don't make an instance of the math class in order to call like the random method, for instance. And so yeah, any data has to do with the class as a whole. That's going to be static. Cool. And then these would be static variables. I also mentioned it's like static methods, like math.random or something, because that's the whole math class. Like, I mean, that's not the best example because like you're never gonna make doesn't really make sense to make an object of the math class. Um, but yeah, so these are all static examples of static variables. And so certain static variables should be accessible to other classes. So say with like the cookie example previously, maybe we want other classes to know like what ingredient our cookie is made with. It's like maybe a person wants to make a cookie and wants to get those ingredients. So we could make these variables public, but we don't necessarily want other people to like other classes to be able to edit these variables. Like we don't want a person to be able to edit like what ingredients we need or how many of those ingredients we need because they could mess up our cookie. Or like in the video game example, like let's say we had enemy class, um, like other classes don't need to know the size of say like an enemy or an assignment A zombies. Um, and so other classes shouldn't be able to like change the starting size because that wouldn't make sense. So, like some static variables we'd want to make public, but we want to make them final as well, and that just means other classes can't edit them. And I mean, really, no one can edit them because they're final. Um, Final just means it can't be edited, um, like after it's initialized. And then some static variables should be private. Like I said, I mean, starting size, I'd say make it private, but like let's say there's something we want for all and like all entities to have like the color. Um, Maybe like other classes could know like the color of our zombies, but we don't necessarily like want them to be able to change the color of the zombies. And so, yeah, all so an example of something that should be private. All zombies should know what the starting size is, but other classes don't need that info. Um, Same, but like maybe something with the color, other classes might need to know that info. So then color could be static and should be final, but it can be public so other classes can see its color. All right. And now for the this keyword. So, this can be a little confusing, but it's very useful and pretty vital for making non-static methods for a class. So, inside the person class, when we make the actual like non-static methods that a person can use, we have to we'll use the keyword this a lot. And so this just represents the object that the method is called on. So, like I said earlier, non-static methods correspond to one object of the overall class, right? And so each of these methods have to be called on an object of said class. But like whenever we're writing the method, we don't know like which objects are going to call that method. So this is just a placeholder for the object that like that method is called on. Cool. So hopefully that makes sense. Here's like a good example. So public void introduce doesn't need any parameters or anything. So it's gonna print hi I'm and then we have this dot first name. So this just references the object that the introduce method was called on, and then the dot says we're getting a property, and first name is the name of the property slash instance variable. So all that this dot first name means is we're getting the first name from the person that the introduce method was called on, and of course printing is just going to print all that good stuff. So, and then let's say we call this method on like the Dorian variable we made earlier. Well, in that case, we're going to substitute like this. This is going to be like referring to Dorian. And so this is kind of just like a nickname for whatever object the method was called on. So we can always refer to it without knowing like specifically what object is going to be called, like the introduce method is going to be called with. Because that would be, I mean, honestly, it would be impossible to know like every object that is going to try and call the introduce method. And we don't want to like have to make like different versions for like any object that would call the introduce method. That wouldn't make sense. So we just use this as like a placeholder for the object the introduce method was called on. So this dot first name would give us Dorian when we call the introduce method on Dorian. So hopefully that makes sense. All right, and then getting into defining behaviors for a class, well, that's by writing methods. Specifically, like non-static methods are going to be behaviors that all like objects of that class can do. And of course, static methods are going to be that like just the overall are going to correspond to the overall class. Very important to know the difference. And so public methods are methods we want the client, which that's just what computer scientists call like the person calling these methods. So, like maybe in some other code we're using like this class. Well, public methods are going to be the methods that like other classes can call. Meanwhile, private methods are methods we keep hidden from the client or like other classes that might be making an object of this class or like using the class that we're making in some way. And so, two main reasons that we would make a private method. So, any methods that deal with sensitive data that we don't want, like the client or any other class to deal with, we definitely want to make those private. Or if it's like a method that other classes never need to access, like if it's just an internal method or a helper method that like logically, no other class is going to need to access that. We're definitely going to make that private. So, yeah, just to restate, private methods, other classes can't access those. They can't call those at all. Public methods, anyone else can call those um, as much as they want. And yeah, we just call like the other class calling that method like the client. So, to determine what access is best for a method, ask yourself whether the classes need to use it and if potentially malicious clients could modify sensitive data by having access to that method. And of course, we do sometimes want clients to be able to edit to change data, which we'll get into in a second. Um, but if it's very sensitive data that like the client either doesn't need access to or should not have access to, definitely keep that private. So, here are some very common non-static methods. A lot of classes you'll be writing will have at least a few of these. And these are accessors or mutators, also called getters and setters. So an accessor, also called a getter, but you should know like the more official name for it too. But accessors return an instance variable so that the client can access and see, but the client won't be able to modify its value. So maybe like in assignment A, we'll want the run simulation class to be able to like draw a zombie, right? And so we'll want to be able to have the um run simulation class be able to access, say, like the size. Um, but we wouldn't want the like run zombie class to change the size per se. And then mutators will allow the client to modify their instance variables. So certain instance variables you will want the any like a client to be able or like other class to be able to modify. Um, you might just have like certain restrictions around that, which leads into very frequently asked question. Why should we make accessors and mutators slash getters and setters if we want to make our instance variables private? I thought the whole point was keeping information from the client, which, yes, we do want to keep information from the client, but we do want to give them limited access, hence encapsulation. So, limited or controlled access is what we want to have clients to have to instance variables. So, of course, there's some instance variables you wouldn't want to have getters and setters for at all. Um, so yeah, we don't add accessors or mutators. For instance, variables we don't want the client to be able to access or change respectively. Um, and so like, and even in cases where, okay, we do want the client to be able to see this data and we do want them to be able to change this data, mutators could check that like the client's input is valid before changing the variable. Like let's say, for I don't know, let's say hypothetically, you wanted like we have like a video game character and we maybe like some other class might be able to edit the video game character's location, but if like some other class tried to give the video game character like an invalid position, we could make sure that like our mutator checks that if like it's provided with an invalid position, like it won't change the character's position in that case because we don't want the character to have an invalid position. So something like that, just making sure that like input makes sense before you actually change the variable's value. And that's just one other way you can control access to the type values an instance variable can have. And so next, how can we define attributes of a class? Well, we've been talking about instance variables a lot, but we add instance variables to say, oh, okay, here's a new attribute that all objects of this class have. So instance variables, they just tell us information about the object. So I mentioned earlier, like a video game character's position on the screen, or like a player's score in the game. If we have a player class, we want to keep track of their score, right? And then say we have like a button class when we're making buttons for our video game. Well, we definitely want to keep track of the size that we are going to draw the button at. Or say we're making like a sports game, keeping track of like the baseball player's batting average. Or even just like a lot of programs will you can pretty common to like write programs to help with like making baseball statistics. Those are interesting. Like a decent amount of progress in statistics has been made just based on like baseball. So something to look into if you're interested. But virtually all instance variables are going to be private because this is just information that is specific to the object. And so it just belongs to that object. And we want to keep that data safe. You might add accessors and mutators so that other classes can like view and or edit that data, but it's just always more secure to make all these instance variables private. All right. And then very big theme throughout like these methods and instance variables is deciding what information should and shouldn't be available to the user. But like what's the point? Well, encapsulation's very important, probably the big vocab word of this unit. So, encapsulation just means capturing related data and behaviors within an object and then restricting outside access to said data and behaviors just to keep like information secure um and all that good stuff. And so, similar to abstraction, encapsulation allows us to hide implementation details from the user. So clients can access your class without understanding how it works. And like we are able to control set access. So they can only edit instance variables through accessors. And we can control like how those accessors will let them change said instance variables. And then there's also some other benefits, which we're getting into here. So yeah, already mentioned hiding information, very important for encapsulation, and like preventing clients from changing the internal state of an object, or only letting them change it in like certain ways or in certain circumstances. And then additionally, hiding our implementation allows us to like change things that are private without the client noticing. So let's say we have all our public methods, right? But let's say we find like a more efficient way to make some of like our private methods or like different way to like have our organize our instance variables. Well, as long as everything in the public interface stays the same, the client will never know the difference. So we can edit and make our code more efficient without the client having to change their code as long as the public interface stays the same. And additionally, just makes your code easier to read and interact with, so it limits the time other people and you spend reading your code. And then also helps to reduce your code's complexity. So, lots of very good stuff. And then I guess on the limiting the time other people and you spend reading your code is part of like documentation for non-static methods is also very important. And I'd say definitely try and get some practice reading documentation with for non-static methods. Can be very like kind of confusing when you're first starting CS, but even just starting with like the string class, being able to understand like how to read documentation for different non-static string methods is useful. And then we use strings a lot in this class, so yeah, always a good thing to like practice reading on your own. Yeah. I believe those are all the important benefits. And then I mentioned encapsulation does some similar things to abstraction, but there is a difference that's important. So, procedural abstraction means we're wrapping code in methods so that users don't need to know like how the method works on the inside. They just need to know how to use the method. So, they need to know like a brief description of like what the method does. They need to know what parameters it takes, and they need to know what it returns or what output it gives, right? And encapsulation wraps data, which in actual like implementation are instance variables, and behaviors, which in implementation they're like instant methods or like non-static methods. And we're wrapping these together in objects and providing controlled access to this data and behaviors. So again, they do similar things because we're keeping implementation details hidden from the user, and they have some similar benefits. But the important thing is encapsulation hides this information in an object and provides a public interface to like use that said object. And then abstraction hides implementation details in a method. So cool. Hopefully that makes sense. And you, of course, you can always ask a TA if you need more of explanation on the difference. Textbook talks a little bit about it too, but TAs can always help, as well. Cool. And then, if I remember correctly, this is the last topic. I could be wrong though, but so not talking about what a reference is. So let's say back to the person example. I'm making a new person object, Dorian. Um, all the same information here. And then, let's say we're making a new variable, person Abby, but we're setting it equal to the previous person object we made. So setting Abby equal to Dorian. And then we're doing something silly. We're changing my email using a setter method. So set email. Then we're providing hacker@email.com into this method. So basically, point of this, it's a setter. It's going to change my email to hacker@email.com. And then we're going to print abby.getEmail. But it's going to print hacker@email.com, which you might not expect at first, right? But sure, we made a new like variable name, but since we never used the new keyword, we never created a new object. So here, there's only one object. We only used like the keyword new once to make the Dorian person. And then when we set Abby equal to Dorian, it's not making a copy of the Dorian object. Abby is just going to be referencing the location of the Dorian object um, in like your computer. And so anything you do to the Dorian object is also going to be done to like the Abby variable. Because again, Abby, it's just referencing the Dorian object. A little confusing, but especially at first. But like also seeing other examples. So this is also, I guess, to note, very different from primitive variables. You don't have to worry about this. Like if I had variables x and y, and like I set x equals 3, and I set y equal to 3, or y equal to x, and then I did like x plus plus. Well, if I print y is still going to be equal to 3 because those are not reference variables, they're primitive variables. But any abstract data type is going to be a reference variable. And so whenever you set like Abby equal to Dorian, it's not making a copy of the Dorian object. It is literally just going to reference the initial person we made in this first line. And so, yep, this is just a visual explanation. This is like creating the Abby variable. It's just pointing to the Dorian object. So, yep, Abby is a reference to Dorian, and just like a nickname for Dorian, not its own object. So reference is just a variable that tells us where to look for the actual object. So Abby just tells us where the Dorian object is. When we do any operations on Abby, it's going to like edit the address of the Dorian object. So if you do anything like change whether the Abby like variable, do like, I don't know, set wears hats or something like that to false, that would also do that to the Dorian object. So yeah. Also, what I was talking about earlier, primitive, it's a built-in Java type. It's going to start 99% of the time with a lowercase letter. And so it's going to store values, not references, which is why, like, if I set y equal to x, well, x just stores the value, right? So it's going to, like, copy, like, 3 into y. Um, and so if you change anything in x, it's not going to change anything in y. But abstract data type, it's a data type that you create or someone creates based on certain attributes and behaviors being bundled together. That's always going to be a reference. And so abstract data type, it's always going to start with an uppercase letter. You see the uppercase letter, you know that's an abstract data type. And then it stores references, not values, which is why we saw in the previous example, like when we set Abby equal to Dorian, it's just referencing the person we made when we initialize the Dorian object. Cool. So hopefully that all sounds good. This is one of my favorite modules. So hopefully you enjoy. I think Studio Object Design is pretty fun. And then I also think Assignment 7 is fun. And it'll be expected next week. As additionally, next week we will be introducing Module 8, Inheritance, which an extension of objects. So we'll be able to do even more cool things with objects. So I will say this module, very important for modules 8 and 9. So make sure that you get like objects, non-static methods, all abstract data types, encapsulation, all that good stuff, like down pat by next week, ideally. And then yeah, also next week there's the module 7 quiz. So thanks for watching. Let us know if you have any questions. Bye bye.